Hello students, today we are going to discuss about electric field lines, topic 1.9. First of all, what is electric field lines? Electric field line explain. Electric field line explain strength of field. Electric field lines explain strength of the field. Let's take one example. Suppose this is a positive charge. As we discussed in previous topic 1.8, electric field of positive charge is outward direction. Is in outward direction. And what about the negative charge? What is the direction of negative charge? Answer me in comment. Okay. Here electric field E is proportional to 1 upon r square, means electric field E depends upon the square of the distance. As r increase according to the inverse relation, E will decrease. As r increase according to inverse relation, E will decrease. As r increase, E decrease, that means density of lines will also decrease, because density of lines is directly proportional to the electric field. If electric field lines are dense, that means electric field is strong. Where electric field lines are rare, that means field is weak. Now, strength of electric field lines depends upon the distribution of electric field lines. If lines are very close to each other, means it creates dense area, field is strong. If they are far away from each other, means they are rarely distributed, the field is weak. Let's estimate density of electric field lines. To estimate it, we have to take a cross sectional area. It's a closed surface, means a closed surface. This area is perpendicular to the lines and also unit in value, means area should be 1 meter square or 1 centimeter square, whatever, but 1. If cross sectional area is unit and it is perpendicular to the lines passing through it gives density of field lines. Lines passing through it gives density of field lines. See, consider the number of lines per unit cross-sectional area which is perpendicular to the lines. Let's consider a positive charge is placed on somewhere, the name is O. Positive charge is Q. Charge is positive, electric field lines are outward and radical. Electric field lines are outward and radical. Let's take a surface. This is a fixed surface and draw in this figure. Next is here. Now you can see that both area are equal. To make them equal, I used a same coin. When the area is near to the charge, field lines are more passing through it. 1, 2, 3, 4 and 5 randomly. But if area is far away from the charge, the field lines are just two passes passing through this area. Means if area is fixed and area is near to the charge, field lines are dense, and far away from the charge, field lines are weak. As we know that electric field E is proportional to 1 upon r square. As r increase, E decrease. But as r increase, the area is increase. These are the two different areas. Why we take this? These are the two different areas for field lines, means entire field lines passing through this. Here see all the field lines passing through this, and in these cases the name is something S and R. Here S and R are the equal area and they have different distribution, and these are the equal distribution with different area. So as R increase, E decrease, but as R increase, area also increase. Now let's find out solid angle. This is a concept to draw the solid angle we studied in chapter number 2, standard 11. This is a solid angle for entire surface. What is the definition of solid angle? Solid angle is sigma is equals to area of one radius square. Definition of solid angle is ratio of area to the radius square. Here solid angle is delta sigma is equals to area is taken as delta S and the distance is r square. Therefore, area delta S is equals to delta sigma into r square. Area delta S is equals to delta sigma into r square. For this P1, delta S1 is equals to delta sigma into r1 square. And for this P2, delta S2 is equals to delta sigma into r2 square. The solid angle is equal for both area. The only change is distance, which is r1 and r2. There are equal field lines are passing through this area. Means suppose n lines pass through both. Now means if the delta S area allows n lines, so unit area allows n divided by delta S lines. Delta S area allows n lines, unit area allows n divided by delta S line. So for a P1, it is n divided by delta S1 is equals to n divided by delta sigma into r1 square, and for P2, it is n divided by delta sigma into r2 square. For both the surface n and sigma are constant. Therefore, field lines is inversely proportional to the square of the distance between them. So, density of field lines is inversely proportional to the square of the distance between them. Let's discuss about the direction of field lines. As we discussed in previous topic 1.8, the electric field lines of positive is outward, and for negative it is inward. So this is a first property of electric field lines. Electric field lines emerging from positive and entering to the negative. First, emerging from positive and entering to the negative. Let's discuss second. For positive charge, electric field lines go ahead, means toward the infinite, because there is a no stop point for the field lines. Similarly, for negative charge, field lines toward the inside. That means field lines come from something large distance, means from infinite. So in a charge free region, electric field lines can be taken to be continuously curved without any break. Two field lines can never cross each other. Why? Because if they cross each other, they give two different direction, and for a single point two different direction is not possible. Single point cannot describe two direction of electric field lines. And the last is, electrostatic field lines do not form a closed loop. They never form a closed loop. Let's see. For the positive, outward, negative, inward, and this is a dipole. Electric field lines emerging from positive, entering to the negative, means in dipole, emerging lines from positive is equals to entering lines in negative. Let's discuss about like charges. Suppose positive, outward direction, but both are repel each other, so the direction is curved like this, and the area where electric field lines are absent is called neutral area. It's called neutral area. And if we put any charge inside the neutral area, there is no force act on the charge, means charge does not realize any kind of force. So this is electric field lines. If you don't understand too much at a one time, watch frequently video and read from the book as maximum as you can. Thank you for watching my video.